Hello, welcome back to the channel. So in this particular video, we shall see the answers or solutions for a few questions which can be related to coordination complexes chapter. So in this case, mainly it was about redox behavior of some coordination compounds, or to be more precise, I can say it is complexes of transition metal ions, how they can function as oxidizing agent or reducing agent. Questions related to those aspects, 3 questions were there. So in my previous video, I had given brief description of oxidation, reduction, oxidizing agent and reducing agent. So if you have not watched that video, please watch that video, and at the end of that presentation, you definitely find these questions, these 3 questions, and you can try them. And now you can verify your answers or solutions with this. Okay, let us come to the first question. So first question, it was this: among the following, the strongest oxidizing agent is. So this question, it had appeared for 2 marks in June 12 examination. See, what we can do in this case is just identify the oxidation state of metal atom in all these 4 cases. So tungsten, it is chromium family. So chromium, molybdenum, tungsten, they fall in one group. So WO4 minus, if you compute its oxidation state, will come to +6. Similarly, this also identical, just same group. 3D metal ion is present here, so this will also be in +6 oxidation state. Molybdenum, that also belongs to the same family, therefore MO4 2 minus ion. So this should also be in +6 oxidation state itself. Right now, last one, rhenium. This is a bit different. Rhenium, it is from manganese family, manganese, technetium, rhenium. So this is in +7 oxidation state, though it is also O4 complex, but overall charge it is minus here. So this is +7 oxidation state. This is just like permanganate ion, MnO4 minus ion, permanganate ion. Similarly, this is perrhenate ion. Now, what they have asked is, among this, which is the strongest oxidizing agent? See, oxidizing agent, as I had told you, it should be capable of undergoing reduction. If its capability to undergo reduction is high, or in other words, if it is, or if it accepts electrons more readily, in that case it can undergo reduction very fastly, or reduction ability to undergo reduction, it will be high for that. In that case, it can act as good oxidizing agent. So if you look from that point of view, and just by looking at this question itself, you should be able to get this gut feeling that this is not the answer, because this is in +7 oxidation state, and these 3 they are from same family and they are in same oxidation state. And maybe you should get the feeling that they are expecting you to compare the strength of these 3, right? Even if you didn't get that, not a problem. See, what happens is, so if you just take these 3, size wise, this is smallest, CR, it is smallest, right? So though charge it is +6 everywhere, charge density, if you talk about, so it is charge to size ratio, that will be maximum here. Therefore, because of highest charge density, ability to undergo reduction or tendency to accept electron, it will be maximum for this chromate ion, right? So therefore, this should be good oxidizing agent here. Of course, rhenium, it is in +7 oxidation state, that is true. But rhenium size wise, if you consider, though charge is high, size if you consider, it goes to it is 4D element. So therefore, ability to accept electron, it will decrease here, and therefore this, if you remove among these 3, definitely this has got more tendency to undergo reduction, and ability to undergo reduction, if it is high, definitely it will be good oxidizing agent, and this should be the strongest oxidizing agent here, and the answer, it should be this option B. Option B is the answer for this first question. Okay, let us go to the next question. Right, this is a bit tricky. On similar grounds, this question has been asked. It has appeared in June 15 examination for 2 marks. So what they have asked here is, for CrO4 2 minus ion, that is chromate ion, this is MnO4 2 minus manganate ion, and FeO4 2 minus ion. So for these 3 species, they have asked you to arrange them in the increasing order of oxidizing power. Which has got maximum oxidizing power, that should come at the end according to the given options, and which has got minimum oxidizing power, that should come in the beginning. Now, again, if you work it out from the same logic, Cr, it is in +6 oxidation state, Mn, it is +7 oxidation state, Fe, it is +6 oxidation state, right? So just if you go with charge, there are chances that we can wrongly conclude this MnO4 minus to be strongest oxidizing agent. Of course, if you know this fact, because these two, they are very common oxidizing agents. If you compare these two, definitely this is strongest oxidizing agent or stronger oxidizing agent than this. It can be just explained based on charge density itself. Mn, it is in +7 oxidation state, and even definitely size will be smaller, and this should have more capability to undergo reduction. That for its potential to act as oxidizing agent, it should be more as compared to this. But if you come to this here, the metal atom, it is Fe. Fe, as you know, its most common oxidation states, they are +2 and +3, right? Of course, +4 is also possible, even +6 is also possible, but they are usually rare. Now, in this case, Fe is in such oxidation state, +6, which is not very stable oxidation state for Fe. So therefore, Fe it has tendency to come back to stable oxidation states like 3+ or 2+. So therefore, in this case, of course, as you go along the period, even size decreases, that factor also matters here. More than that, what I assume is that Fe, it is in unstable oxidation state. This matters a lot, and because it is in highly unstable oxidation state, it can readily accept electrons than these two species, and therefore this will be very strong oxidizing agent among these three. So if you just look at that fact, if you can identify this to be strongest oxidizing agent, then also you can straight away conclude that this should be the answer, right? So this order, it is readily explainable, not a problem. Highest, it is this iron compound, next comes this manganate ion. So I think I have made a mistake. They have MnO42 minus, what they have asked is, so yeah, that will be good, because everywhere it will be +6 oxidation state. Please note this change. This should have been 2 minus, and Mn should have been +6 oxidation state, right? So maybe Mn, when it is in +7 oxidation state, I'm not sure. I should just check the redox potentials. Sometimes it can even be stronger oxidizing agent than this. So this should have been in a +6 oxidation state. So if it is in +6 oxidation state, of course, so there will not be any problem at all. Just based on size itself, we can conclude that this is strongest oxidizing agent. It makes your life easier. But here one more additional point is that iron, it is in unstable oxidation state, right? That also matters. And considering all these facts, your answer, it should be this option A. Option A is the answer for this FeO4. It should have highest ability to oxidize some other species. Let me just verify this question and answer once again. So this is from June 15 2 marks question, and June 15 2 marks question. Let me just verify 1 second. June 15 2 marks. Yeah, option A is the answer. So whatever I have said, it is correct. Fine, let us go to the next question. This is interesting question. So just whatever is needed to get the solution, only those aspects have been given here. So I have skipped the question. So what the original question was, it was about H2O2. H2O2, it is undergoing reactions with these species. H2O2, it is reacting with this species, with this species, with this species, and with this species, and in acidic or basic medium. So, and in that case, what type of reactions are expected? That is the question. See here now, one thing, H2O2, though it is usually, it can act as oxidizing agent, but in this case, depending on the species, so it has undergone even a reduction sometimes. So to solve this question, truly speaking, you should know the reactions of H2O2. But sometimes the beauty of MCQs is that even if you do not know much aspects about the question, or exactly you do not know the answer, even then you can try to find out the answer, because you are given with options, and by carefully looking at the options, there will be some possibility in some cases to find out the answer, and that possibility is there in this question. That's the purpose I have taken this question purposefully. And take these words. Those who can solve questions in this manner, definitely they succeed in competitive exams, because the syllabus is so vast that you cannot know each and every aspect, and then only by knowing exactly all aspects of the question, or all concepts behind that, then only if you think that you answer questions, that goes difficult. So whatever little you know, based on that itself, you should be able to answer the question. So this is good example for one such question. See, look at now. I just concentrate on this side. So here it is FeCN6 3 minus to FeCN6 4 minus. Just by looking at that itself, you can say that it is 1 electron addition, right? Or even if you work out the oxidation state here, Fe it is in 3+ oxidation state. Same thing I have written in condensed form here, or in a different manner here. Fe, it is converting itself from 3+ to 2+ oxidation state. It is gain of electron. So this reaction essentially it is reduction reaction. Similarly here it is reverse of this reaction. Fe, it is getting converted from 2 plus oxidation state to 3 plus oxidation state, which is essentially loss of electron, so it is oxidation, right? Then further, these two, just if you identify the oxidation state of Mn, it is 7 plus to 2 plus, so this is definitely reduction. And if you do not know about other reactions, so definitely you will be knowing about this reaction, because Mn7 plus or MnO4 minus, it can act as oxidizing agent in acidic medium. So if it is acting as oxidizing agent, this point has been made clear in my previous video. If it is oxidizing agent, by itself it will undergo reduction. So therefore this reaction, it occurs in, essentially this is a reduction reaction of MnO4 minus in acidic medium. At least you can find out this, even if you do not know about mediums for other reactions. At least for this reaction you can find out that. Fine. Last one, 2 plus to 4 plus, easily you can notice this. See, 2 plus, it is getting oxidized to 4 plus, this oxidation reaction. So let that happen in acidic medium or basic medium, doesn't matter. Now how we can arrive at the correct answer? Just by looking at the options. So first what I have done is what kind of reactions these are, that I have mentioned here. Now we can come to options. Look at option A. So what they say here is, first reaction 1, it goes with A. So 1, it is oxidation in acid, they say it goes with A. But what you have found is A reaction, it is not oxidation reaction, it is A reaction, which is reduction reaction. So what they mention is 1A. So this cannot be the answer. You can just verify the other things too, but readily you can here find out that this cannot be the option. Then come to question option B. Option B, so it is 1B, oxidation in acid 1. B is, yeah, oxidation. It's correct. Similarly, it is 2D. So 2 is oxidation in base. 2 is D. So it's also oxidation. What they say is correct. Then third option, if you go, it is reduction in acid. Reduction in acid, it is said to be here 3C. So reduction in acid C. And it matches well with what we have estimated. Then option 4, it goes with A, reduction in base. So this is also reduction. So option B, for timing, it is matching everything well, right? This could be the answer. But to make sure that option C and option D are not correct, that only makes sure that option B itself is the correct answer. Let us just verify one or two things from this option C and option D. We shall verify. See, if you look at option C, 1C they say. So 1 is oxidation in acid, they have said, but C, what you find is reduction in acid. So again, straight away here you can see that first thing itself is not matching. This cannot be the answer. Then last option is 1D they say. So 1 is oxidation in acid, they say it is D, oxidation, fine. So oxidation, it matches well. Next we shall look at, so what they say is 2A, oxidation in base, but see what you find here is, they say 2 is A, but A is reduction. So therefore this also not matching well. So now you can conclude that even this is not the answer. See, like this, now you have removed option A, option C and option D. You are just left with option B, and that should be the answer for this question. Though you are not very sure that option B is the answer for this, so you can just conclude that option B is the answer, because you have you are sure that option A, option C, option D, it cannot be the answer, and therefore option B should be the correct answer for this, and option B, of course, is the correct answer for this, right? So this reactions you can again verify, and that is correct. So 1, it goes with B, which simply means that, see, oxidation in acid, that goes with B. So H2O2, it reacts with this species to convert, it oxidizes this species, right? And in acidic medium, that is correct. And 2D is oxidation in base, So 2D, Mn2 plus to Mn4 plus, this should also be the fact that in basic medium, Mn2 plus, it should be getting converted itself into Mn4 plus by H2O2, right? Similarly, this 3C4A, they should also be facts, right? So even if you do not know these facts, you can easily find out the answer for this question. That was the purpose why I had taken these questions, and these things are very much necessary. With little knowledge what you have, you should be able to find out the answer, and that has been very well applied to this question. Okay, these were the 3 questions which had appeared in previous examinations related to this concept. Thank you for watching this video. Thank you again.